Hello everybody, and thank you for dialing into this month's EMEA webinar series around SDN. My name is Jake Stevens. I'm from the EMEA marketing team here at F5, and I'll be facilitating today's webinar. So if you have any issues with audio or viewing the actual presentation, then please direct your queries to me at the EMEA marketing alias via the chat box. Also, we will be fielding a Q&A session at the end of the presentation. So if you do have any questions during Michael's presentation today, please do send them in to me and I will field them to Michael at the end of his presentation. So without further ado, I will introduce our speaker today, who is Michael Brown. He is a Field Systems Engineer Manager in the UK, and he'll be taking us through today's presentation. So thank you, Michael.
Thank you, Jake, and thank you everyone for joining. You know, this is actually, SDN is one of my favorite topics, and it's quite timely actually in that, you know, I recently came back from Cisco Live, and that was on the heels of VMworld that was in Barcelona a couple months ago, 3 months back or so, you know, and I had a lot of conversations with customers, some, you know, ranging from just kind of wondering what SDN was, you know, how do we play in that space, we being F5 play in that space, you know, how do we integrate, what are the values, what are the benefits, why are people looking at SDN? So this is really a timely webinar. So to that end, hopefully I'll answer a lot of those questions, because I'm sure some of the people listening today have very similar queries. So let me proceed. And you know, it all really, you know, SDN is not at the heart, but a major part of today's data center transformation. You know, I've been in the business probably longer than I care to admit, and what's going on in the data center now is probably the biggest evolution that I have seen in my time in the IT. You know, you have everything from, you know, BYOD, Internet of Things, the cloud, SDN. You have so many things, and it really is around because the data center has to transform itself to really allow businesses to, or allow IT actually to progress and advance at the speed of business. You know, users are more demanding than they've ever been before when it comes to applications and services that applications require. So the data center has to transform to today's users, to today's customers' demands. Everything is around, really revolves around applications, and that is probably a change too from you know, 2010, even 8 years ago. Applications really are king. Nearly half organizations have mobile applications, right? I mean, I know everybody on the call today has a device that they bring to work and they connect to work systems. They run applications, right? This did not happen 5, 8, 10, 15, 20 years ago. Part of this data center transformation, really being able to support applications that are mobile. The growth of the web. Now this is a bit dated. 37% of the web, 30% growth in the web in 2013. There are 630 million websites at the start of 2013. By the end of it, there were 861 million. That is a massive amount of growth. And according to a statistic that we have come across here at F5, there's 641 new applications per day. I mean, you see it. You see all the applications depending on, I mean, the applications can run on a desktop, your laptop, and I already talked about the number of applications that can run mobile today. So where are these technology shifts? Okay, the technology shifts are around the applications themselves. I already touched upon mobility. We have to, the data center today has to be able to support mobility and the applications thereof. What about applications that run on-premise and in the cloud? Okay, the Internet of Things that I already talked about. And today's advanced threats, right? There's not a day that doesn't go by that there's not some news article about some breach. I just read something yesterday where there was a hack that's been in progress, I think since 2010, 11, I can't quite remember, where the hackers have escaped with $1 billion US, right? That was just in the news yesterday. You know, and then with all of this, with the Internet of Things, mobility, having applications being able to burst out to the cloud, you know, how do you provide that quality of experience? How do you bring your applications to market quick enough when you have to take into consideration all of these things, right? You have to keep them secure. You have to be able to deliver them. How do you monetize them? You have to be able to get to market quick, because if you are in second place in the market, guess what? You are the first loser. This is an application economy. The application experience has to be fast, and you have to get the application to your users quickly. Users stroke customers. This, as well as these other things that that are on this slide, are putting pressures on today's networks in order to scale. Applications doubling every 4 years. Data volumes doubling every 18 months. That is absolutely staggering. And OpEx costs doubling every 8 years. Why? Because you're having to support a more and more complex infrastructure. Maybe you have the solution that is multiple vendors, adding complexity to your network, adding complexity to your data center. All of these things and the stuff that I mentioned on the previous slide, literally putting pressure on networks and IT administrators and network administrators to scale and to keep up with the speed of business. I keep talking about the speed of business. That's what it's all about. It's about the applications that are going to keep your organization in business. So, you know, I talked about some of the challenges. So I mentioned that there are challenges. So what are these challenges? I already briefly mentioned the complexity of today's world. Multiple vendors, the complexity of being able to support, you know, thousands, if not tens of thousands of applications on a network. How do you keep up with that? Okay, there has been, in the development world, in the application development world, they're becoming more and more agile, being able to develop applications faster. But unfortunately, the networks have not been able to keep up with that growing demand and ability to create these applications. How do you run, when you have all of this complexity, how do you run efficiently? Right? If you have multiple vendor solution, if you have a lot of manual intervention, you may have many CLIs, different GUIs, different APIs, and how does everything talk to one another? For instance, you know, how you provision storage and data. How does it talk to the network? How does the storage talk to the compute when you're trying to provision these for your applications? Okay, all of this together adds to complexity and can make deployment of applications inefficient. Today's world demands that you're flexible, right? You have to be able to upgrade quickly. You have to be able to, you know, if there's a security flaw in something, you have to be able to patch it quickly. You have to maintain certain maintenance schedules. These are just some of the demands that are on today's data center. So the challenges in scaling today's modern data centers have slightly been addressed with being able to virtualize first compute and then virtualize storage, okay? But in today's world, for most organizations, there still is a bottleneck in the network itself. And what is the bottleneck? Well, you know, you have an application, you develop an application, you have to then have a network infrastructure configured a certain way with certain services for this application, and this all has to be first designed by an architect. Then you have your network engineers or administrators that actually have to manually configure these networks to be able to support the various applications before they can actually get deployed. And what happens is, because there is a lot of manual intervention, you wind up having a lot of error. According to IBM, 95% of all IT security breaches are due to human error. That to me seems a bit high, but I have seen numbers that range from anywhere from 33% to 75% on up to IBM's number. Okay? Regardless, I mean, the point is that when humans are involved, the more complexity an environment, the more complex a configuration, the higher degree and risk for error. I don't know if you recall the Microsoft Azure outage back in, I think it was November. By the way, this was their second big one that they had, because they had one in the beginning of February, February of 2013, sorry. And both were due to manual processes that failed to execute properly within their network. It was caused by a change to the configuration of the storage service, but that didn't talk to the network. So it was supposed to improve performance, but instead the configuration caused some code to execute that really caused the storage service to go into an infinite loop, preventing communications with other components within their system. This was all due to human error. You automate that, and maybe that error, in fact, most likely that error doesn't happen. You know, you can kind of look at the way we are going, the path we're going down with automation of our provisioning of resources within our data center to what the airline industry has done over the last X number of decades. Okay, autopilots have been around since the start of aviation, basically, but they've automated more and more components within an airline, within an aircraft, basically starting since the 40s, 50s, 60s. Okay, the individual components were automated. However, the components themselves still did not talk to one another. So there still was a lot of manual intervention by the pilots themselves. So in the late 70s, the airline industry started designing something called what they call a glass cockpit design. It basically was almost like, think of it as almost like a central controller that touched many, many different components. So suddenly, we still have airline pilots, right? But suddenly the airline pilots don't have to touch as many different components, different measures and different levers and knobs within their cockpit. They go to a more central location because now the components with this glass cockpit design talk to one another. So if they make a change one place, that talks to other systems that may actually need to know that a change has been, so they can automatically, those other components can automatically, as opposed to a pilot first going to one component, making a change there, then going to the next component, making a change there. These components now talk to one another. And if you can look at the statistics yourself, the safety record of the airline industry is impeccable. I mean, it really has improved over the decades. This is one of the many reasons why. So liken that to what we're trying to achieve in the data center itself, or compare that, I should say. So enterprise, to achieve this, they need a new answer, right? Because right now they're manually, especially when it comes to the network, they're manually going to those components. We need these components to start talking to one another, okay? as I talked about Agile development briefly, development of applications has been pretty Agile for a long time. In fact, I have a very strong software engineering background, and I remember, quite a few years ago when I was still coding, and we talked about Agile development, and we talked about, having to come out with releases more than once a year. And at the time, I was like, wow, how are we going to do that? Well, it's through Agile development. I mean, how often now, today, do you have to upgrade your applications? I mean, every time I go onto my iPhone or my iPad, I have to, my applications need to be updated. Same thing with my applications on my desktop. Right, and everybody knows about Microsoft Security Patch Tuesday, right? Every Tuesday, we have some new patches. It's because of Agile development. So development has gotten really fast at going to market, okay? Being able to develop the apps really, really quickly, okay? So once they got quickly, then it was operations. Okay, so how does operations get this actually out in the environment? Okay, so that became kind of a bottleneck, but now with things like DevOps and being able to provision things automatically, virtualization of the of compute and virtualization of storage has almost become like code. So they're kind of deploying code automatically through DevOps. So now they're able to develop the storage required, the compute or the service required, along with the applications really, really quickly, okay? But the bottleneck still, and in today's world, still seems to be the network. This is what SDN can address, okay? The network configuration today is very, very manual. The configurations are not stored in a repository. We don't have like a network get where you can actually store configurations. I don't know if people have heard of GitHub, but where you can store, code and little applets, if you will, to use and build, bigger apps. We don't have this type of repository for storage configurations. Okay, this is where SDN can help. Getting things to market faster and stop having the network become the bottleneck. It really allows organizations to provision quicker with consistency and automation. With the automation, the consistency, and the policies, not only will you be able to get to market quicker with fewer errors as well. So, a great question is, what exactly is SDN? Everyone knows, software-defined networking, and it somehow has to do with the virtualization of networking. But it's interesting, the meaning of SDN is really kind of evolved. Some people think, is it open flow, L2, L3 switch control that's automated? Is it an overlay, a virtual network? Is it service chaining? Is it commoditization? No. Sorry, excuse me. Is it programmability? Is it abstraction? Well, the answer pretty much is yes. The answer pretty much is yes. It can be any or all of that. And I'll explain as we progress through the remainder of this. Okay? Here's a definition of SDN. We like to use this at F5, but this pretty much is kind of an industry standard definition. If you were to go to any of the vendors at L2, L3 that support or provide L2, L3 services or L4 to L7 services, you are going to see this. It's not a technology. It literally is a family of architectures to operationalize network and improve the time to market, reducing risk, costs, errors, all the things that I've mentioned before. And it uses open APIs. Okay? So operationalizing the network, what does that mean? Okay? Well, in order, operationalize the network is going to take advantage of the things that you see here. Automation, abstraction, standardization, programmability. Automation, the ease of provisioning, automated configuration tools, ability to rapidly provision VMs and other applications. Network agility. For example, the ability to allocate network resources to a group of servers on demand, not having to manually configure these. Abstract the configuration of it from the actual data plane or from the actual data itself, and I'll get into that in a little bit more. Standardization. Do things the same way. The greater the standardization with abstraction, the greater the efficiency within your environment. Why? Because you don't have to go to 50 different management consoles to try and get something done. Go back to the cockpit that I talked about, right? Instead of an airline pilot having to go to his instrumentation panel and touch different levers, he'd have to go to one place, and the systems would talk to one another. Okay? Go to one place, have the computer, have the components behind there actually know what to do and communicate with one another. Programmability, being able to program the network and enable specific applications to have specific networking characteristics. Yeah, it's great to have templates and policies and that sort of thing, but sometimes you need to slightly tweak this. So in order to have in order to successfully operationalize your network, at times you're going to need to slightly tweak things. Okay? Excuse me. And if you don't do this, you're not going to be able to adapt to the speed of business. And if you don't adapt to the speed of business, you lose. Okay? Operationalizing your network is really the next evolutionary step in data center transformation, in assuring your adaptability and survival, really. So, operationalizing the network with SDN. If you look at the slide, I put this slide up a few slides ago, okay? But how does it change once we've operationalized the network with SDN? So basically, instead of a manual scripted configuration that is managed by your engineers or administrators, we basically going to put a control plane in. We're going to separate out the controlling of what happens at the L2, L3 level into a programmable control plane. Okay? It's going to use more open APIs to make configurations instead of having it tied directly to the data plane and the physical device itself. It's going to provide a way of standardization. I've talked about standardization a couple of times now. It is going to be the way that you interface, or the interface, I should say, between your engineers, the architects, the control plane, and all the devices at L2, L3. So it can drive, basically, a repeatable configuration of all services across the network, as well as centralize that knowledge of what the network and the services are supposed to look like. A famous economist once said, repeatable configuration is an example of an anti-fragile pattern, a stable pattern. And that's what, if you operationalize your network, if you have the ability to have a repeatable configuration, you will increase your likelihood for a stable network. Because of the abstraction of configuration, eventually what SDN will be able to do is drive the ability to look at a picture or a state of a network configuration and be able to take a change and model what that change will do to your environment. Will it add latency? Will it actually even work? So if I make a change to port X and port and policy Y, how does that change the flow of traffic? This is eventually where SDN will get to. You will be able to look at a change, test a change before actually implementing a change. This is where the market wants to go. The issue we have with the network is slightly different than what we have with DevApps or application development, in that the blast radius for the network is huge. If something goes wrong in the network, it affects many applications, potentially thousands or tens of thousands of users or worse, customers. Okay? It has a huge impact on your business. It's not like if a particular application doesn't work. If a particular application doesn't work, that application's down. Okay? If the network doesn't work, major portions, depending on how you have your network segmented, major portions of the data center will be down. All right, so the common question is, after explaining what SDN is and its benefits, how does that fit in with the things like what F5 provides, the services F5 or other ADC vendors? How do they work together? Let's start what a traditional SDN controller or environment might look like. Here you have your control plane, your SDN controller controlling, and that's where you make all your changes, okay? And you have your data plane. And somewhere in between, you have, your virtual overlay network, kind of really sitting in between your L2 and L3 fabric and your SDN controller. Okay? So that takes care of, but there's so much, that takes care of L2 and L3, but as we know, there's a lot more that you need for your applications that run on these software-defined networks. So that was a kind of a vanilla software-defined network. If you just want to get a network out there and a virtual network out there and have L2, L3 services, all right? Your routers, your switches, okay? But what about everything else that needs to be applied to applications on that network? That network that's getting provisioned automatically. What about the application security, the application performance, DDoS mitigation, identity access management? If you look at this picture, there are a lot more services at the L4 and L7 level than layers 2 and 4. So SDN by itself is somewhat incomplete if you're trying to operationalize your network and trying to operationalize and get your applications and all the services required to market quicker. Okay? You need to operationalize and automate the services that need to be applied to those applications running on that automated network. So what is interesting is these layers are actually more difficult to standardize and operationalize because unlike layers 2 and 3 that are stateless networks, there's no standards. There's standards for L2 and L3. We know what data is going to be passing through L2 and L3. We know what a packet looks like, okay? But as it moves up, it can change because applications are different, right? SDN began as an academic project to lower the cost and introduce agility and programming into layer 2, layer 3, the stateless portion of your network. But it didn't take into consideration the complexity or consequences of applying that same exact architecture to services delivered at layers 4 and 7. The layers of the network are naturally divided in two for a reason, because the compute, the I/O, and processing models of stateless network are dramatically different than the stateful networking, the higher levels of the network. So, going back to that couple of slides, this is kind of how you would have. This is what it would look like if you were also automating the services required for the applications running on that network. You might have some sort of orchestrator, right, that would automatically link to the SDN controller using RESTful API as a means of communication. Then that orchestrator would be responsible for talking to your layer 4 through layer 7 fabric. Okay? It doesn't have to be that way. Okay? And in fact, today's vendors, including F5 actually, do a lot of talking directly from the SDN controller directly to that L4, L7. But the way F5 is headed, and I think eventually other vendors too will probably follow suit, is that everything is going to go through an orchestrator that understands that L4 through L7, and when a change is made by the SDN controller, that change be communicated to the L4 through L7 orchestrator automatically. The L4 through L7 orchestrator will then provision the services that are absolutely needed for the applications that are running on that particular network. So let's map what we talked about a few slides ago with regard to SDN, the automation, the abstraction, the standardization, the programmability. Okay, that was all talking about L2 through L3. Guess what? We can overlay that, no pun intended, but we can overlay that, those same services or qualities that SDN brings to L2 to L3. We can bring those same qualities, services if you will, to the L4, L7 services, and we call that software-defined application services, okay? Because if you're able to scale the network now with SDN, you need to scale the services as well, okay? Software-defined application services. So how do we scale, and how do we map the same way that we're scaling with at the L2 through L3 with the L4 through L7? Well, let's talk about automation. The ability to automate the deployment of these services. Again, the services like load balancing, application security, perimeter security, identity access management. I talked about this a few minutes ago. Abstraction and network agility. This is actually quite important. The ability to be able to apply services to any application, regardless of the network or encapsulation protocol that they're using. And I'm going to talk about this a little bit more in a couple slides. And standardization. If you choose to standardize on a platform that provides software-defined application services, then you're going to provide consistency on the creation of the policies, the configurations, the interfaces. You'll have a consistent UI for all of these services. Okay? This will allow you to reduce OpEx because you'll have to train fewer people on a variety of different types of vendor solutions in this space. So if you standardize, you reduce OpEx. And programmability. I kind of touched upon this a couple slides ago, but a good software-defined application services solution will give you the flexibility you need to tailor the functionality of the services you need for your applications. Templates and policies are great. However, we know not all applications are created the same, and even the same application, functionality changes oftentimes from customer to customer to customer, from group within an organization to a different group within an organization. Having the ability to program and tweak that is vital to being able to get to market or to your users quickly. And this is just kind of a picture that shows you the components in one picture that make up software-defined application services. There's a couple of references in here that are kind of geared towards F5, but again, most vendors, if they're providing a good software-defined application services, they will have a lot of these things. And I touched upon programmability. I touched upon standardization, right? The having a consistent platform. Okay, automation. I show partners in here, right? A good software-defined application services is going to have open solution, being able to plug in to partners' offerings, okay? Being able to work with, the HPs, the VMwares, the Ciscos, whoever it is. If you're using a good open solution, you will be able to leverage the partner ecosystem and the services that they're providing at the L2, L3 level. Connectivity issues. This is one of the reasons why I almost took this slide out, but I thought that this slide would be good because it it explains one of the reasons that you actually need SDN, because all of these network protocols, encapsulation protocols, sorry, don't really speak well to one another. If you can abstract that, then they will, it doesn't matter which one the application is actually running on or leveraging. The next slide shows this. So the abstraction that you need between the applications and the network, this picture shows you the abstraction that you need. So in the middle there literally would be your software-defined application services being able to literally abstract whatever the encapsulation protocol is. Doesn't matter, the services will still be able to be applied. And I kind of already touched upon this too. You really need an intelligent orchestrator, an intelligent orchestrator that has northbound, southbound APIs, right? Being able to talk to the SDN controller, being able to talk to various modules, being able to talk to the cloud, burst out automatically to the cloud if you need to burst out to the cloud, because as we know, more and more, that's part of the IT data center transformation that I touched upon in the beginning of this slide, at the beginning of this presentation. And you know, a couple slides ago, I mentioned partners, and if you go back to one of the slides that I touched upon, that I had earlier in the presentation, I talked about SDN is a set of processes, right? It's architectures. It is operationalizing your network. That requires oftentimes an entire ecosystem of partners. Okay, I have some partners here in different areas, in different silos, but they actually, some of them can work across a lot of these silos. Okay, so we need to, a good software-defined application SDAS solution is going to require you to be able to, your organization, or should work with all of these partners. It should be open enough and leverage these partners if you're going to have a good software-defined network solution as well as a software-defined application services solution. Because remember, I cannot stress enough, it's not a technology, it is a set of processes. It is operationalizing your network. And the summary says it says it perfectly. SDN is about operationalizing the entire network and requires an ecosystem, not typically just one technology to do everything. Okay? May leverage a technology for your L2 and L3 services, and then standardize on a technology for your L4 through L7 services. And the benefits will be able to address the issues that have and are still in the data center today. Improve time to market, being able to provision and get your applications to the market quick enough. Reduce the risk. Remember I talked about pilots and pilot error being reduced through automation and through systems being able to automatically talk to one another. When a configuration is made, change is made in one component, it automatically is communicated to another component. Operationalizing your network, connecting it to your compute, connecting it to your storage, having that end-to-end software-defined data center will reduce the risk and reduce operational expenses. So with that, I hope you got a lot out of that. It was, I know, kind of a lot of information, but it is timely, and it is based on the conversations I've had recently at the conferences that I mentioned at the beginning. I see more and more and more organizations going to an SDN.
Great, thanks, Michael, for taking us through that. So, as you will know, we've had quite a few questions come in during that. So, we've got about 10-15 minutes worth of time to go through this, so we get started. So it's still great in theory, but a lot of people have been asking me, do you know of any organizations that have actually implemented an SDN strategy and how they went about that?
Yes. Actually, like I said, I've been to quite a few conferences and talked to people. Have done quite a bit of reading, and it's interesting. People implement it for different reasons. Okay. I don't know how many people are familiar with Nippon Express, but they're kind of a global logistics supplier. And they were moving, and I mentioned this in my right at the end, they were moving to a complete software-defined data center. And they had moved the compute and they had moved the storage, but the network was the bottleneck. So they implemented SDN to eliminate that bottleneck. And once they did that, well, I should say not just that, but by going completely to an software-defined data center, including the network, they reduced the server unit space by 70%, power consumption by 80%. I think the failure time, let me look, the failure time was reduced failure time by 98%. It's eliminating that human intervention. And they eliminated the network outsourcing fee because they were able to automate it, as opposed to having to have the network, having a network specialist come in anytime they needed to make a change. There was another hospital actually this hospital happened to be in Japan, but their use case was multi-tenancy. They were constantly introducing new network-connected medical devices, but they needed, for regulation and privacy, they needed to insulate the data and the connectivity from other departments within the network. So software-defined networking allowed them to easily or more efficiently implement multi-tenancy. Now, I'll mention a couple of big names that I talked with Fidelity Investments. I'm sure everyone's familiar with Fidelity Investments and Goldman Sachs. They both believed that in order to ensure growth, that they had to go to a software-defined network. Because again, they were not able to expand quick enough. Their business was growing too quickly. Their network was not going to be able to keep up. Now, they didn't hit that, but they knew that. They had the foresight to realize. So it was to ensure growth. That was one of the use cases. And data isolation, multi-tenancy. Mergers and acquisitions in that space happen all the time. And, not every user is deemed the same class of user and can see the same data. So multi-tenancy and to ensure growth were both drivers for both Fidelity and Goldman Sachs.
Okay, cool. And so another question related to the implementation of these SDN strategies. What are the main things that people should consider when evaluating an SDN infrastructure?
Okay, that's an excellent question, because first and foremost, if you go to the one slide that I referred to, talked about what is SDN. First of all, all the stakeholders in your organization have to agree what SDN is to your organization. Is it all of those things that I mentioned, those 7 things? Is it one of those things? Is it just operationalizing the network? Is it just separating the control plane from the data plane? First of all, you have to remember what, first and foremost, everyone has to agree what it is. Identify applicable use cases. What are the problems you're trying to solve? Don't just implement SDN just to implement SDN, just because it's a bright, shiny new object. Solve a real problem with it. I highly recommend that it fits in with other IT initiatives. If you go down this route, right, you're giving yourself the ability you're using open source. You have the ability to either purchase open source or develop the functions and the applications yourself. Do you purchase or do you develop yourself? You do have to understand, though, if you do decide to develop yourself, everything that goes with it, all the overhead of development, maintenance, support, that sort of thing, right? And if you decide to purchase, then do you go with the multi-vendor solution and play system integrator? Or do you go with one vendor best of breed? So that's another thing. And I think probably, don't get hung up on architecture purity. You're trying to solve a solution, right? Your organization is trying to make money. And don't introduce any risk. We know CIOs hate risk. So understand what the risks are. Understand that, or try to make a case that, by introducing SDN into your environment, you're reducing risk. But the CIO is going to push back how much risk is going to be introduced in trying to eliminate risk. So understand what the risk is. And really, again, I'll go back to, the organization there to maintain a business and make money. Focus on your goals. Stabilizing the network, standardization, driving down costs. Okay? That's what I would...
Okay, great. So you gave us a couple of enterprise examples for SDN.
Yep.
I've had a couple of questions around SDN and the SP market. So one of which is SDN ready for solutions in the SP network? And if it is, how does SDN help mobile operators in terms of CapEx and OpEx?
Well, and what's interesting is a lot of people are confused between SDN and network function virtualization, and SP are already using network function virtualization, really virtualizing all the L2, L3 levels. The service providers absolutely can benefit by software-defined networks. In fact, if you think about the numbers of customers, the number of mobile devices being introduced into I said the organization, but just into the consumer world as well. Every single day, the number of devices. In order to keep up with this added demand, they have to introduce SDN. So they've already done the leveraging the network function virtualization. They are absolutely adding on the SDN piece now.
Okay, good. I hope that is good news for those people that were asking about that. So I've still got 3 or 4 more questions to get through. We've got plenty of time to do so. So with regards to operationalizing the network, do you have any suggestions about what are the emerging vendors, products, standards that will enable SDN across an existing mix of kind of network vendors and products that are typical in kind of all enterprise networks?
Yeah, I mean, almost if you go to any of the key vendors, the big names, I mean, the HPs, the Dells, everybody is playing in that space. They all want you to obviously go down their route, but they all have, and that would be, remember I talked about standardization on a platform. You can even standardize on a platform for SDN and operationalizing your network. But they all have services or consulting services that they're very, very well versed in being able to work with multiple vendors. Okay, and you also have service providers like or system integrators like Dimension Data and others at that that are in that are very, very versed in software-defined networking and can put together and can completely operationalize your network from L2 all the way up to L7.
Sure. Cool. Good. So if you go back to slide 13, if you can, there was a question specifically about that. What is your view on the operational challenges introduced by SDN by the underlying network becoming centralized and automated? For example, how would it impact debugging and low-level operational tasks which network engineers are used to in a legacy?
Yeah, none of that goes away with it. I mean, absolutely none of that goes away. What goes away is the manual configuration. So debugging, networking, looking at logs, I mean, all the things that your network administrator is used to today all of that is still there. What goes away, again, is the creation of policies. Because you create the policies, once, is the configuration of individual networks. It's the automating of that. In theory, if done correctly, there will be less debugging. But if you do have to debug, all of the mechanisms are still there to debug as you do today. You just shouldn't have to do as much.
Sure. Okay. So good news. So do you see any difference between intra-data center SDN and WAN/inter-data center SDN? And do you see one single SDN controller for both of those things?
A lot of industries would require you to have separate, because you have to keep your external data separate from external traffic separate from your internal traffic. So it would depend, are you bound by regulations? Whatever you're bound by the physical network, you would still SDN, you would still be bound by those same things. You would still take the exact same things into consideration. So as with a physical network, everything could go through the same controller, or it could go through a different controller.
Sure. Okay. So there's options.
Yes.
Okay. So there's one last question. There's kind of 3 steps to it. What steps would you recommend someone to follow in order to transition an existing traditional network into an SDN solution? Your first kind of 3 steps.
Okay. So first of all, I'll go back to one of the things that understand what you're trying to achieve with SDN. Okay. So that's first. Get buy-in what SDN is. I would then go to a vendor. Well, it depends on how much developer resource you have. You also have to decide, do you want to take this on yourself? Do you want to purchase? Okay, some of the things I talked about before. But first of all, do research. Understand, do you want to purchase? Do you want to develop it yourself? Understand what problems you're trying to solve. Go small. Start small. Start with a small portion of your network, an application or 2. Okay, before you roll it out completely. These were the things. This is probably where I would start.
Sure. And do you know of any tools out there, products maybe, that actually physically help with this transition?
Yeah, what I can point you to are a number of resources, right? I mean, there's a great resource. There's a number of resources that you can go to. You can go to onf.org. You can go there. That's Open Network Foundation, which was really the father of SDN, if you will. One of the fathers actually helped start that. That points you to how to get started. There's SDXCentral.com, which used to be called SDNCentral.com. All things software-defined networking, but they've kind of expanded recently, hence the name change. That will point you to a number of resources as well. OpenStack will give you some tools on how to actually, if you go to OpenStack site, on how to really monitor actually monitor some of the software-defined components that you need. So there's lots of resources out there. I would start with ONF. I would start with SDX, and it will point you to many tools. You can even go to the vendors themselves, right? Again, I mentioned Dimension Data, but there's lots of other vendors, HP, VMware. I mean, they will all point you to tools. Some of them will point you just to their tools, but some will also point you to all kinds of other tools that aren't necessarily tied to them.
Brilliant. You actually answered my final question, which was about monitoring SDN. So you mentioned that there's a resource for that as well. So there are no more questions. Thank you very much for going through that presentation with us and answering all of those questions that came through.
Thank you.
Just to let everybody who's still on the call know, the slide deck and the recording of today's webinar will be sent round to you guys later this week. I will just point you to our next webinar, which is on March the 26th at the same time, 12 p.m. in the UK, which is around SSL. I will leave it to Michael to close down the call. So thank you very much.
Yeah, and I just thank you again, guys. And as guys and gals, as I said, this SDN is something that I've seen a lot of customers really looking at. It's very similar to the way cloud was a few years ago. A lot of people were talking about cloud, and then I saw more and more interest. It was, before it was initially exploratory, and then I really think it could be good for us to eventually having cloud projects. I'm seeing the exact same pattern or same path, if you will, with SDN. It was just kind of exploratory. What is this SDN thing? To, this might work for us, to very real projects. So thank you for your time, and good luck.